Hello, everyone. Welcome to Science Buffs, the ultimate podcast for STEM enthusiasts. I'm Abby,
And I'm Sam.
and thank you all for tuning into this week's episode. It's been a while since we recorded. As you know, we batched some episodes before we left on our little break because I went to Hawaii. Sam had her big Japan trip, which we'll have a bonus episode on next Monday. So be ready for that. Um, but yeah, it's been a while. So, Sam, what has happened since you've been back from Japan?
Oh my God. Well, I got sick again, which we talked about a little bit when I was back from Japan. But really not a whole lot. What about you?
Oh, we've just been sick for like a month now.
Yeah, you guys are struggling.
I feel like we're never sick. And then all of a sudden, I think just like with the plane flights and stuff, because we got sick on the way back from Hawaii. And then when we were in Michigan, I guess I didn't get sick and Jason didn't get sick, but the baby got sick. So that was a whole thing. Then we came back, and then like 3 nights ago, we were all throwing up in the middle of the night, and we're still
Poor
recovering from
baby.
that. So I'm a little tired, but that's okay. We had a good Christmas, and yeah, it was all really fun. So I can't complain too much, but I'm ready to be healthy. So
Yeah, you guys have been in just like a sick cycle for a while.
well, it's annoying because it's like sick for 5 days, and then we'll have a break, and we're like, oh, thank God, this is amazing. And then we get sick again. As you can tell in my voice, as I
Yeah.
almost choke. But yeah. So how was your Christmas?
It was good. My family does like Christmas Eve and then
So does mine.
that's yeah, they
That
did
should be our
Christmas.
poll for the week. Sorry to interrupt, but our poll should be like, is your big thing Christmas Eve or Christmas Day?
Yeah, my family's big thing is Christmas Eve, and then we do like surf and turf every year, so it's like steak and lobster.
Dang,
But I
nice.
don't eat lobster, so it's just turf for me.
Just the
Yeah,
turf.
so that was fun, and then just like cleaning my house has been good, and then trying to sleep a lot, but like not sleeping as much as I would want to.
Yeah. Yeah, I feel
Yeah.
that. You went to the disco again,
Oh yes, I did. I went to the
frequenting
disco
the
again.
disco at this point.
I know my friend is like really into the disco music, so I went with her and it was super fun. But I was like feeling pretty low energy. I feel like I'm still kind of low energy, and
Yeah.
she just like was unhinged, like having so much fun, and I felt bad. I was like, I just can't match your
Like
energy
I'm
level.
not matching the vibes right now.
Yeah, but it was super fun. So
Our nights again were so different tonight. We were going to the disco because that was like our sick night, or like maybe the night we were recovering. I was like taking a bath bomb, like bath, bubble bath, doing the whole thing, just like soaking. And you're like, I'm going to the disco.
yeah,
I was just,
I am jealous, honestly.
oof, it was quite the thing. But good, we're back and we're excited for the podcast for 2024. So thanks for coming back after our break, everyone.
Little
Thanks for
break.
listening.
Yeah.
So yes, we just ordered like a million supplements, so we should not be sick anymore, and we can get on a good recording schedule. So,
Yes. I'm
so
going to New
perfect.
York City next weekend, so I'm excited about that.
That's gonna be awesome. I'm excited
Yeah,
to hear. How long? So you're just there for the weekend, like a long weekend?
Thursday through Sunday. So I'm
Okay,
super excited.
that's a good amount of time.
Yeah, we're gonna go see Wicked. I'm very excited.
Wow, that's fun. And then are you staying at her apartment while you're visiting one of
Yeah,
her friends from college?
yeah. One of our friends lives in New York City, so and I'm gonna stay with her on her couch. So
Awesome.
that'll be
Love
fun.
it.
I can
You'll get the
save
full New
money.
York experience that way.
Yeah, exactly. So I'm super excited about that. But I need some good
Perfect.
sleep before then.
Yeah, for sure. You got to rest up.
Yes,
Okay. Well, are you ready to get into our topic?
I'm ready. I'm so excited.
Here are your three clues. This thing is used for both exploration, like exploring new things, and also war.
Oh, okay. Ships.
No, but like kind of warm. Okay, there's a lot of environmental and life control systems on board or that need to be engineered.
Um, Aviation as a whole.
What if I just did the broadest episode ever?
Just like
Like,
aviation.
I'm just doing planes.
Wait,
No.
the I mean the International Space Station's not used for war. So
Well,
I don't know.
do we know? No, I'm just kidding. Okay. The third clue, a very similar thing was very recently in the news.
Aliens.
Not the exact thing, but people got this confused. It'll make sense. I don't know. That's a bad clue, but it'll make sense once it's revealed.
Aliens.
No, but good guess. It
Um,
is. Oh,
submarines.
yes.
Oh,
Submarines. The submersible is not a submarine, and we're going to talk about why.
okay.
But yes, today we were talking about
Oh my gosh.
submarine.
Are you talking about the Titan submarine?
I'm just talking about submarines kind of in general.
Got it. Okay.
I don't
Okay.
know. I'm sure it's somewhere in my outline because I think I have like some famous submarines, but
That's the Titanic one, isn't it?
oh, the Titan, like
Titan.
the
Yeah.
submersible.
Yeah.
Oh yes, yes, we were talking about that one. Sorry.
Okay.
Yeah, that didn't give me much.
Okay.
Yeah, we're talking about this, and we're going to
Okay.
talk about the difference between that submersible and like what an actual submarine is, because a lot of people were like, "Oh, it was a submarine that went down and imploded," when really it was a submersible, and I was confused as to what the difference was. So we will go over that.
Got it. Okay.
Okay, so let's talk a little bit about the history of submarines. So obviously, a submarine is a vessel that goes underwater. So again, it can be used to explore the ocean. There's a lot of like research submarines, but there's also like wartime submarines that can be used to launch like missiles and weapons and stuff. So a little bit about the history. 1578. The first submarine design was drafted by a man named William Bourne. It never got past the first drawing stage, but basically his design was based on ballast tanks, which could be filled to like submerge the vessel and then evacuate, or like if the water is evacuated, it'll be filled with more air, and that will make the submarine rise, which is actually the same um principle or same mechanism that is used in today's submarines. So right from the beginning, he was on to something. 1620, a guy named Cornelius Drebbel, who was a Dutchman, conceived and built an oared submersible. So like with oars attached. He was the first, his
What?
design, yeah,
What does
which
this look
seems like
like?
crazy. And I don't think it went very low like these very first submarines, but
Were there like people inside and then it was like
yeah,
closed off and then you're like oaring?
I think so.
That's so interesting.
And we'll post a picture of all these on the stories, like how it has like
Evolved.
evolved over time. Yeah. So his design was actually the first to address the problem of air replenishment while submerged. So his was a little bit getting more complicated with like the life systems, how we were talking about as one of the clues. Um, okay, then 1776, year of America's birth. Some guy during the Revolutionary War was like, I'm going to make this other submarine. So David Bushnell builds the one-man human-powered turtle submarine. The colonial army attempted to sink the British warship HMS Eagle with the turtle submarine. So this is the first time that a submarine was like attempted to be used in war. It says the first submarine to dive, surface, and be used in naval combat. Its intended purpose was to break the British naval blockade of New York Harbor during the American Revolution. It says it has slight positive buoyancy. It floated with approximately 6 inches of exposed surface. So, like the first submarines weren't even totally underwater. It was still had 6 inches exposed, and it was powered by a hand-driven propeller. So
Oh my goodness.
very kind of primitive. The operator would submerge under the target, and using a screw projecting from the top of the turtle, he would attach a clock detonated explosive.
Uh,
They would just like paddle over to the boat and like stick something to the bottom and like paddle away. That was the
that's
first
crazy.
like war submarine. Isn't that fascinating?
That is crazy. Oh my goodness.
Yeah, I was
I
like,
also love that it's called the turtle.
I
That's like a
know.
big deal.
Yeah, it like makes it a cute name for like a war machine, but
Yeah, it's like super
um
dangerous.
okay, 1798, Robert Fulton builds the Nautilus submarine, which incorporates two forms of power for propulsion. One was a sail while on the surface, and then a hand cranked screw while submerged. So you would like sail out to where you wanted to get submerged to, and then once you were submerged, you would like have another screw thing to
Oh,
navigate.
interesting.
So we're getting a little bit more complex. 1895, John P. Holland introduces the Holland 7, later the Holland 8 in 1900. It says the Holland 8, with its petroleum engine for surface propulsion and electric engine for submerged operations, served as the blueprint adopted by all the world's navies for submarine design up until 1914. So this was like kind of the birth of like modern submarines in the
Wow.
1800s. So we're getting somewhere. 1904, the French submarine Aiguette, I want to say, I'm probably pronouncing that wrong, is the first submarine built with a diesel engine for surface and an electrical engine for submerged operations. Diesel fuel is less volatile than petroleum, so this was a big innovation, switching fuel types. And it's the preferred fuel for both current and future conventionally powered submarine designs. A lot of them now are like nuclear, but if you're going with the conventional fuel, this is where it's switched to diesel.
Interesting.
Then
Do you know like what percentage of submarines now are like diesel versus nuclear?
I don't know. I'll have to look that up. My impression was that like the vast majority of at least military ones are all nuclear. Um, but I'll that's a good question. I'll look that up and put in the stories.
Yeah.
Okay, then nothing crazy happened on this timeline till 1943, where the German U-boat, the U-264, is equipped with a snorkel mast. This mast, which provides air to the diesel engine, allows the submarine to operate the engine at a shallow depth and recharge the batteries. So
Oh,
they're developing the
interesting.
U-boat. And then in 1944, a different German submarine, the U-791, uses hydrogen peroxide as a fuel source, which
What? Okay. Do you know how
like
many people were in the U-boats? Like how many people it could hold?
let me just Google how many
Okay.
people could fit in
I was
a
just
U-boat.
curious, like how big of a sub it is.
Okay, 30 men,
Wow. Okay. So it's not
10
very big.
torpedoes, and 30 men. It was 200 feet long, and it could remain underwater for nearly 2 hours.
30 men and 200 feet long. That's
Oh,
not very big at
we go
all.
over like the sleeping arrangements in a little bit.
Yes.
Oof, I would not want to be on a submarine.
I wouldn't either.
Okay, 1954, the US launches the USS Nautilus, the world's first nuclear powered submarine. Nuclear power enables submarines to become true submersibles, which means able to operate underwater for an indefinite period of time. So, like, these other ones would have to go up in charge, and like they would only stay submerged for so long because they would have to like replenish the air, recharge the engine, whatever. The nuclear propulsion is where it can stay underwater for however long you want to.
Yeah.
Okay, 1958. The US introduces the USS Albacore with a teardrop hull design to reduce underwater resistance and allow greater submerged speed and maneuverability. 1959, the USS George Washington is the world's first nuclear powered ballistic missile firing submarine. So that's where, like, that's kind of where we are at now, basically. That's where the timeline stops. 1959 is like, okay, now we can shoot nuclear powered ballistic missiles, and they're nuclear. Oh, yeah, I said nuclear powered ballistic missile firing submarine. So that's what it looks like today. That's how we got here to submarines.
Definitely, we've made big improvements since the days of like oaring.
Oh my gosh. Yeah. And it's so crazy. It showed a picture of I think it was like the third iteration of the submarine, the turtle. It's like a big ball, like just a circle, and a guy is like standing kind of upright and he's like pedaling, and like
Oh my God.
it's just a crazy design. So it's really evolved a lot.
You'd have to be super fit.
Yes, for sure. Um,
I would panic. I think I'd have a panic attack.
Oh, yeah. I mean, oh gosh, I've heard one of my brother's friends, I think, um, was like in the Navy on nuclear submarines. And it was just like the horror stories of having that many people like on top of each other, and you have to like rotate bunks. And you also, we'll get to this, but you also don't know whether it's day or night. Like they're down there for like a month at a time. You have no concept of daytime, nighttime. You never see the sun. So
Yeah,
you would just go crazy, I think.
that's terrible.
Okay, so how do submarines actually work? So a submarine floats when the mass of the water it displaces is equal to the mass of the boat, which is very similar to just like regular boats. We've talked about like, I guess we haven't talked about boats on this podcast before, but like you think about how a boat floats and it's like the water that it displaces needs to be the weight of the boat. It's the same exact thing with a submarine, but the goal is to have it actually sink a little bit underwater, which is
Yeah.
interesting. So the displacement causes buoyancy, and regular boats can't control or change its buoyancy. But the thing that's different about a submarine is that it can. So with those ballast tanks, it's like the same exact thing as that first design. There's tanks on the outside of the hull, and you can fill them with water, like allow them to fill with water, and it'll sink a little bit. And if you still have a little bit of air, that controls your depth. And then there's pressurized air tanks on the submarine that when you want to resurface, will pump air back into the ballast tanks and expel the water out the bottom, and you'll rise to the surface.
Wow.
So that's how it controls its depth. So this says to keep the submarine level at any set depth, the submarine maintains a balance of air and water in the trim tanks so that its overall density is equal to the surrounding water, which is neutral buoyancy. So when the submarine reaches its cruising depth, the hydroplanes are leveled so that the submarine travels level through the water. So that's like a whole other thing of engineering that I didn't think about before I was reading about this, that it's not just a given that the submarine will like go down level. It could try to nosedive or go, all sorts of different like attitudes, I guess. And so there's all the tanks in there work to also stabilize it like horizontally and, make sure it's level. The submarine can steer in the water by using the tail rudder to turn either starboard or port. Okay, do you know if starboard is right or left, or if port is right or left? Starboard
is right. Port is left.
Good job. Good job. You passed the quiz.
I have my boater's license.
Oh yes, I forgot. that was an easy one.
That was a good quiz.
And the hydroplanes control the fore aft angle of the submarine. So again, I'll post a diagram with all of the different parts of the submarine, but there's many things that keep it all level. In addition, the submarines are also equipped with a retractable secondary propulsion motor that can swivel 360 degrees. So there's a backup there. All right, when the submarine surfaces, the compressed air flows from the air flasks into the ballast tanks. Water is forced out of the submarine until the overall density is less than the surrounding water, and it rises. We talked about that already. So that's kind of how the navigation works on it. Let's talk about life support. So there's 3 things that you really need when you're talking about a submarine. Because it's a closed vessel, you have to maintain your air quality, maintain a fresh water supply, and maintain temperature. That's like the environmental life support 3 main problems. So air quality is an interesting one because basically the air that we breathe is made up of 4 main gases: nitrogen, oxygen, argon, carbon dioxide. Obviously, as we breathe in the air, we consume the oxygen and we convert it to carbon dioxide. So it says that exhaled air contains about 4.5% of carbon dioxide. Our bodies do nothing with the nitrogen or argon. So since we're in a sealed container, there's a limited supply of air. So oxygen has to be replenished as it's consumed. And like otherwise, everyone on board will suffocate, obviously. But also, like we talked about in the Apollo 13 episode, carbon dioxide has to be removed from the air. So they have to have a way to scrub the air of carbon dioxide. And then the other thing that I don't think I really, thought about was the moisture. So again, you're in a sealed container. There's no like evaporation really in this like sealed metal thing. So there's gonna be a lot of moisture building up if you don't take care of that problem as well. So there's usually oxygen in pressurized tanks, or there's an oxygen generator, which forms oxygen from water using a process called electrolysis. It must be electrolysis, right? Yeah.
Yeah, they do that on the ISS too.
Okay, yeah. So a lot of this is very similar with space because they also have the scrubbers, like we talked about, in the Apollo 13 episode to scrub the carbon dioxide from the air, which is like the soda lime chemical reaction, carbon dioxide scrubbers. Yeah. And then they remove the moisture just by doing a dehumidifier, or there's some chemicals that will remove moisture from the air. So all of those have to be in place for the air quality. Then for freshwater supply, most submarines have a distillation apparatus. So this is really cool. It takes seawater and then it goes through the whole distillation process and it just produces fresh water into the submarine. So it's not like you have to take a fresh supply. Like you'll never run out of the fresh water as long as your process, continues to work, I guess. Yeah. It heats the seawater, turns it into water vapor, removes the salts, and then cools it into a collecting tank. So that's pretty simple. And then temperature. So the temperature of the ocean is 39 degrees Fahrenheit usually at the depth that they're cruising. So it would get really, really cold because the metal of the submarine would just conduct all of that into the hull and it'd be too cold for the crew. So basically it says the electrical power for the heaters comes from the nuclear reactor, diesel engine, or batteries. And the batteries are only used really in an emergency. So normally the heat is just generated from the nuclear reactor or the engine. So that's how they keep a crew alive when down in a submarine. Okay, talking a little bit about the power supply, which we did a little, but like for modern power supplies, for modern like submarines power supply, nuclear submarines obviously use nuclear reactors. They also use steam turbines and reduction gearing to drive the main propeller shaft, which provides the forward and reverse thrust in the water. It says an electric motor drives the same shaft when docking or in an emergency. They also need electric power to operate all of the equipment on board. So that's where the diesel engine comes in that I mentioned. It burns fuel, or they also can use that nuclear reactor. And then again, in emergency situations, like if none of that's working, there is a stash of like emergency batteries on board that will last for a short amount of time, mostly just like get them up to the surface. It's not for any like extended use really.
I see.
Okay. So a diesel submarine, they say, is a very good example of a hybrid vehicle. So most diesel subs have two or more diesel engines. Diesel engines can run propellers or they can run generators that recharge the very large battery bank. Or they can work in combination with one engine driving a propeller, one driving a generator, and then they have like a mix of power. So it's kind of interesting like how all of these things like space has a crossover with submarines, but then all of it, I feel like we can learn stuff with like hybrid vehicles and just our cars and everyday life and stuff like that. So
they're very similar. I took did you take that humans in space or human spaceflight class in college?
I don't know if I ever did.
With our professor was a previous shuttle astronaut.
Yeah, I don't think I could ever get in because it was always so packed.
Yeah, somehow I made it, but it was really interesting. But we had our year-end project was to design an ECLS environmental
control and life support
system for the ISS. So a lot of this sounds very familiar.
Yeah, it's really fascinating how, I mean, it's like all the same stuff, I guess, to keep you alive. That makes sense. But it's like interesting how it's adapted to being underwater because basically like it's the same thing. You can't go outside for either one. Right. Like you'll die immediately if it's not completely enclosed. And so when I set out to do this, I didn't fully put together how it was going to be like essentially the same thing.
It's so interesting.
Okay, last thing for, I guess, this section is navigation. So how you know where you are? Because light obviously doesn't go very far down into the ocean. Like you lose light immediately.
Is it
So
sonar?
yes, there is some sonar involved. So it says submarines are equipped with navigational charts and a lot of sophisticated navigational equipment. So on the surface, they can be located with GPS. That's pretty simple, but the system does not work once it's submerged. So underwater, same thing with a lot of spacecraft, they use inertial guidance systems. So it keeps track of the motion from a fixed starting point using gyroscopes and other sensors to see like your velocity, if you've turned. So from that initial starting point, they can know exactly where you are from that starting point. So again, very, very similar to space. It says the inertial guidance systems are accurate to 150 hours of operation, but they have to be realigned by other surface-dependent navigational systems after that amount of time. So
150 hours?
Yeah. So
that
at some point
seem like
they have
very
to
many hours.
I know. How many days is that? Like 6, maybe?
Yeah.
Something like that.
That's like a week.
Yeah, it's not
That's interesting.
crazy. And then it has to be somehow
because they have that
realigned.
drift. You have that like what do they call it? Like the gyroscopic drift or something like that.
Right.
Where you have to
Yeah.
recalibrate them.
Right. So I definitely thought it would be longer than a week. But I guess it makes sense, like if there's ocean currents and stuff, although you'd think the sensors would be able to fix that. I don't know. But it says the submarine can be accurately navigated and be within 100 feet of its intended course with those sensors on board and with those systems on board. And then, like you were mentioning, to locate a target, a submarine uses active and passive sonar. Do you know what sonar stands for?
Oh man, I feel like I learned it at some point. I don't remember.
I don't think I would have known this, but I feel like it was a trivia question like not too long ago for me.
Yes.
Sound navigation and ranging.
Sound. Oh, got it. I was like SNR.
Sonar, yeah.
Got it.
They're like sound navigation.
Sonar. Got it. Okay, interesting.
So the way sonar works, you probably know, but active sonar will emit a pulse or pulses of sound waves that travel through the water. They reflect off the target and then they return to the ship. So that's how you know like the distance something is from the ground, or the distance the ship is from the ground, or the distance the ship is from its target. So you calculate that by knowing the speed of sound in water and then the time that it takes for it to go down and travel back. That's how you can tell the depth. Passive sonar involves
just like quick interruption. Yeah. Sonar reminds me of, have you seen Finding Dory?
Yes, because this says whales, dolphins, and bats use the same technique for locating prey, echolocation.
Yes. Do you remember it's like the beluga whale. I think she can't see very well, so she's like figuring out how to use her sonar. Yeah. Her like, yeah.
Yeah, she like runs into stuff. She keeps like running into stuff.
It just reminded me of that. I had to bring it up.
Okay, yeah, no, that is the same mechanism. So, okay, passive sonar involves listening to sounds generated by the target. So sonar systems can be used, well, I guess that's it for passive sonar. I was just keep reading, but that's like basically the end of passive sonar. If it's creating a sound, you know how far away it is based off of the sound. Right. Sonar systems can also be used to realign inertial navigation systems by identifying known ocean floor features. So this is interesting because you don't have to actually surface every week to realign. You just have to find a known spot on the
interesting
ocean floor.
Okay.
So that's something can stay down for longer than a week. Okay, I think that is it for this article. This is on How Stuff Works, which is a really good article. Oh, the one other thing I did want to touch on is rescue operations. So when a submarine goes down because of a collision with something, like another vessel, which would kind of be crazy because the ocean, I feel like it's just so, it's like two planes colliding. It's like, I feel like there's so much other space, but it does happen where they'll collide with each other. Some sort of canyon wall or mine or something on the ocean floor. If there's an onboard explosion, basically what will happen is the crew will radio a distress call to like their, ground station, or they can also launch a buoy that will transmit a distress call with the submarine's location. So it depends, obviously, like an emergency can vary widely, but depending on what the disaster is, what the circumstances are, what has gone wrong, a lot of times the nuclear reactors will shut down. So the submarine, this would be an example where the submarine switches to battery power by itself, because you don't want, in an emergency situation, a nuclear reactor to continue to go if it's not controlled. So in this case, it says the crew has like 4 primary dangers. One is the flooding of the submarine. So if water starts coming in, it's going to probably like implode or flood at the very least. Oxygen use has to be minimized. Again, carbon dioxide levels will rise, and then the batteries will run out. So you have to surface before the batteries run out, and you have no heating systems.
Yeah.
So usually any rescue attempts have to be successful basically within 48 hours of the accident, or else it's very unlikely that they'll survive. There's deep submergence rescue vehicles, which are obviously specific vehicles to go down and try to rescue crews. Those are called DSRVs. They can travel independently to the downed submarine. And then there's a mechanism where they latch onto the submarine, open a hatch, and then the crew of the submarine can escape into the rescue vehicle.
Wow.
So obviously a very kind of specific thing has to go wrong in that case. It can't just like implode, but if like your reactor fails or something like that, you can use this emergency hatch. And then to raise the submarine, typically after the crew has been extracted, pontoons can be placed around the submarine and inflated to float it back up to the surface. So that's usually how rescue missions work.
Interesting. Okay.
Yes. So, okay. And then I guess some of the incidents that have happened in submarines is the next thing, or is the last thing I was going to go over. And we'll talk a little bit also about the Titan. Okay, so these are the top 5 disasters for submarines recently, and this is what convinced me I will never go on a submarine. So in 2008, something called the NERPA K-152, which is a Russian submarine. It was going through its final sea trials before getting commissioned and officially joining the Russian Navy, when there was like a mixed crew for some reason of civilians and sailors who were on the vessel, and they were putting them through the test, the submarine. And suddenly the fire extinguishing system was activated. So it sealed the first 2 bow compartments and filled them with a fire suppressing chemical. Just, oh my gosh. And it couldn't like open up, and it killed and injured everyone who was in there. So 20 people were killed and 41 people were injured.
That's terrifying.
And it actually showed that like a singular person accidentally activated the fire system. So anyway, then they leased that same ship to the Indian Navy, and it's now a part of the Indian Navy. So that's interesting. Then for the number 4 is an Argentinian submarine called the Era San Juan. And it went missing during a routine trip from one port to another. There was a crew of 44 people, and it just failed to reach its destination. It couldn't establish any communications. There was a whole international task force that tried to locate it, but no one ever found it. And it says the British, bitter rivals of the Argentinians ever since the Falklands War of 1982, even sent a specialized unit to help in the efforts. It took a year for the search and recovery forces to find the missing submarine, but obviously they found it at the bottom of the sea, and they still don't know why it sank. So that's always a possibility as well. Okay, the Indonesian submarine went missing in 2021, which I don't even think I heard about. So did you hear about this?
I don't think no, I didn't. 2021.
Yeah. So it failed to make contact after a deep sea dive 60 miles off the coast of Bali. And it was scheduled to live fire torpedoes during a training event. And so they found that there was catastrophic damage when they were trying to fire the torpedo, and the whole thing sank.
Oh my gosh.
And came apart in 3 parts. Okay, China had a submarine. Terrifying. I know. That would be so bad. But so China had a submarine in 2003 that It says a fishing trawler found the Ming-class submarine sailing peacefully just above the waves close to North Korea. The Chinese fishermen tried to make contact with the submarine, but it continued to just float aimlessly until other warships arrived and discovered that all 70 of its crew was dead inside. So no catastrophic damage. It was just like floating there with a whole dead crew.
Do they know what happened?
It says that they were participating in an exercise that simulated realistic battlefield conditions in which subs might not surface and make comms for days or even weeks. An investigation revealed that the engine had failed to shut down, an investigation revealed that the engine had failed to shut when the submarine submerged and used up all the oxygen, so they all just suffocated.
Oh, that's miserable.
It's like, don't go in a submarine is what I'm getting from this. Also, and then Russia, the Kursk, which was it says the undeniably the worst submarine disaster of recent history. In 2000, the nuclear powered guided missile submarine went missing during an exercise in the Barents Sea. It had a crew of 118 people. And it says an investigation of the recovered sub revealed that one of its torpedoes exploded while the crew was preparing it for launch. So it
oh no,
like the entire thing, it blew up the whole thing. Actually, 23 of its crew managed to survive both blasts because so here's the whole story. The Russian submarine was using this certain type of torpedo designed to sink American aircraft carriers, which runs on hydrogen peroxide, which is highly volatile, it says. So the explosion triggered a second larger detonation of the nearby torpedoes. Contemporary reports state that the second explosion, which sunk the submarine, was so large that seismographic stations in Europe and Alaska picked it up.
Oh my goodness.
So it says 23 of the crew survived both blasts and barricaded themselves at the back of the vessel. So there were all these efforts to save them, but it says newly elected Russian President Vladimir Putin refused international help, including the U.S. Navy was going to go help and find them, but they refused help for 5 days before eventually saying that they could, but the crewmen had already died.
Oh my goodness.
So that's
terrible.
So the Titan now is, I just looked up like very short of like what is the difference between a submersible and a submarine. So it says, this is an article from the Seattle Times. It says the vessel that went missing in the area of the Titanic is classified as a submersible, not a submarine, basically because it does not function as an autonomous craft. So it relies on a support platform to deploy it and to return.
Oh, interesting. Okay.
A submarine can like go out and venture on its own, submerge, come back and like do the entire thing by itself. For a submersible, you have to have like a whole support crew and support.
Interesting.
Platform.
Okay.
That's really the only difference. It can still go down, navigate all that stuff, but it just doesn't have all of the systems on board.
Yeah.
So that's pretty much it. I mean, that answer is pretty simple, but
yeah.
So that's why it was a submersible. But that was big news a couple months ago. That's in like all of the pop culture recaps that I'm seeing at the end of 2023 is like,
that's a big one.
That's a huge one. That's on all the lists, which that was a crazy time in history.
That was, yeah.
We were all so united and it ended so mean.
Yeah.
I was like getting upset.
Not the best side of the internet for a while.
No, people were like cheering that people died. I'm like, because they were billionaires, and I was like, excuse me.
Yeah.
It was crazy. It turned out like so united. We were like, find them. That was sad. But anyway, so that is submarines and side of submersibles.
I learned so much. I loved that topic.
Good. I'm glad.
It's different from anything we did before.
Yeah, but weirdly the same.
But weirdly the same. No, you did fantastic.
Thank you. Well, thank you all for watching and listening. Again, if you like video podcasts, we are on video on Spotify and also on YouTube every week. And episodes come out every Wednesday. We have bonus episodes every other Monday now because we will, we're back for the new year. So be on the lookout for those. We're going to recap Sam's whole Japan trip. So make sure whatever platform you're on, subscribe, listen, and share with a friend. 2024 is going to be our year to grow the podcast.
Yes.
So refer other science buffs to our podcast. Anyway, that is all for this week's episode. Thank you all for listening, and we'll see you next week. Bye, everyone.
Bye, everyone.